One of the main reasons that we use factorization in algebra is to help us simplify expressions, so we can cancel things, just like we can cancel in fractions. In this example here, you'll notice that there's two fractions. There's the 3 divided by x plus 2, and it's multiplied by the x plus 2 over 4. So if I was doing in normal fractions, that's similar to 3/5 times 5 over 4. You can see there are two fractions. What just makes it a bit more confusing is that one part of the fraction has this x plus 2 instead of a simple number. Don't forget that the x plus 2 is really got brackets around it like that. We just don't bother putting them in. So like normal fractions, the one on the right, I could cancel 5 goes into 5 once, 5 goes into 5 once, and that would give me 3/4. So we can do the same thing here with this fraction. Even though it's got algebra letters in it, we can cancel the x plus 2 goes into x plus 2 once, x plus 2 goes into x plus 2 once. So that whole thing is equal to 3 times 1, which is 3, and over 1 times 4, which is 4. So it simplifies right down to 3/4. Just be careful, you can't cancel this x here on its own with this x here, because it's got something added onto it. You can only cancel things that are multiplied and divided. So because this bracket, this whole bracket, is multiplied by this fraction with the bracket on the top, we can cancel whole brackets, but not what's inside the bracket. With fractions, like the one I've got on the right, where there are 3 fractions multiplied, when you're cancelling, you can cancel any number that's a numerator with any number that's a denominator. So I could cancel 3 goes into 12, 4, 3 goes into 3, 1, and I could cancel 3 goes into 15, 5, 3 goes into 3 once, 4 goes into 4 once, 4 goes into 16, 4. And that would simplify that a lot. You notice I'm picking any number that's a numerator and a corresponding number on the bottom that's a denominator to do the cancelling with. We can do the same thing here with fractions. So if you notice on the one on the left, with all the algebra in it, there is an n minus 8 on the top and an n minus 8 on the bottom. So I can cancel those. N minus 8 goes into n minus 8 one time, n minus 8 goes into n minus 8 one time. I can also do the same thing with n plus 2 and n plus 2. They go into each other once. There are no other things that are the same on the top and the bottom. So that means that this is simplified to 1 times n minus 5 times 1 times n plus 4 over 1 times 1 times n minus 6 times n minus 10, which is a lot simpler. Notice I didn't write the 1's down because 1 times anything keeps it the same. When you're dividing fractions, you turn them upside down and multiply them. So that's what we need to do here. So I've got 3 over x plus 2 multiplied by x plus 2 over 5. Remembering, of course, there's really brackets around these x plus 2's, and they will cancel because one's a numerator, one's a denominator, 1 time there, 1 time there. So the answer is 3 times 1 on the top, 3. 1 times 5 on the bottom, 5. 3/5. In this next question, we need to do the same thing. It's division, so you need to rewrite it with as a multiplication and flip the fraction. So m plus 4 bracket m minus 5 over m minus 6 multiply and flip the second one. So m minus 6 will be on the top, m plus 4 will be on the bottom as a denominator, and now I can cancel. M minus 6 once, m minus 6 once, m plus 4 once, m plus 4 once. That's it. So it equals m minus 5 over 1, which is just the same as m minus 5. That one's simplified quite a lot. In the previous questions, the expressions were already factorised. In the questions we're doing now, we'll have to factorise them first before we can cancel. So, when I look at this first fraction, can't do anything with the 6, but on the top, something goes into 4b that also goes into minus 8, and that's 4. So I take 4 out as a common factor, and that leaves me just b minus 2. Don't forget you can check it. 4 times b is 4b. 4 times minus 2 is minus 8. Now, when I look at that, I can see that there are two things multiplied on the top, the 4 and the bracket. Underneath is the 6. I can actually cancel this 4 and the 6. 2 goes into 4 2 times and into 6 3 times. So that has simplified to 2b minus 2 over 3, which is a simpler version than the original one because the fraction has a smaller denominator. In the next expression, let's have a look. I can't do anything with the top or the numerator, but I can factorise the bottom, the denominator, and something that goes into 18 and minus 21 is 3. So 3 times 6c would be 18c, and 3 times minus 7 would be minus 21. Now I can cancel the 9 and the 3. 3 goes into 9 3 times and into 3 once. So it just means I end up with 3 on the top line, and 1 times the bracket means it stays the same, and I don't need the bracket anymore, 6c minus 7. So you can see that's a lot simpler than the original one. In this next example, we'll have to do some more factorising before we can simplify. So let's do that. 3 and 12, well 3 goes into both of those, so 3 bracket h plus 4 is the factorised version of 3h plus 12, and on the bottom part 3 goes into 6h and into plus 9, so 3 at the front, 2h plus 3, so the 3's cancel, 3 goes into 3 once, 3 goes into 3 once, so I end up with h plus 4 over 2h plus 3. In the question on the right, the thing that's in common is the h's. We've got h squared there, which really means hh, another h here, and a h squared there. So the common factors are actually h's. So I'm going to take a h out of the top, the numerator, and h times h would be h squared, and 12 times h would be 12h. On the bottom, take a h out of that, and I'll get h plus 9. So then the h's can cancel. H goes into h goes into h once, and I end up with h plus 12 over h plus 9. In these next questions, we've got monic quadratics to factorise, so I need to factorise the top one first. Now let's put the double brackets because it is a quadratic, so I'm going to get 2, and I'll keep the x plus 4 on the bottom. Now if I'm factorising the top one, the factors of 4 and minus 4 are 4 and minus 1, and if I use those I'll actually get 3, so x plus 4, x minus 1. If I expand that out, I'll get the x squared plus 3x minus 4. Therefore, I can cancel x plus 4's. That goes into that once, that goes into that once. So I just end up with x minus 1. So that's a lot simpler. In the next question, same thing, except I'll have to factorise the top and the bottom, or the numerator and the denominator, so I'll need 4 sets of brackets. If I look at the top trinomial and look at it, you can see that 8 has factors of minus 8 and 1, and that would make minus 7. So I can put h minus 8 and h plus 1. The factors of 2 are 2 and 1, and if you add them together you get 3. So that'll be h plus 1, h plus 2. The h plus 1's will cancel into each other once. So that means I end up with h minus 8 over h plus 2.